In this video, we're going to talk about another example regarding impulse and momentum. A bullet of mass 50 grams is fired from below into a suspended object of mass 450 grams. The object rises through a height of 1.8 meters with bullet remaining inside the object. Find the speed of the bullet. If we're going to declare now our first variable, which is m1, okay, we're going to use m1 for the mass of the bullet, which is 50 grams. If we're going to convert it to kilograms, this is 0.05. M2, on the other hand, is the mass of the suspended object, which is 450 grams. In kilograms, that is 0.45. Okay? In addition to the given, we have the height at 1.8 meters. So we are required to determine the speed of the bullet at u1. u1 is the initial speed of the bullet. Now, if we're going to proceed the solution, if we're going to illustrate the problem, we have a bullet, okay, which is fired below. The mass of the bullet, again, is 50 grams or 0.05 kilograms. This suspended object with a string is actually has a mass of 450 grams or 0.45 grams. The problem requires us to solve for the speed of the bullet prior hitting the suspended object, okay? Or the initial velocity of the bullet in u1. The speed of the bullet is u1. The second body is at rest or u2 is equal to 0, okay? The suspended object or second body, the initial velocity of this one is 0 or u2 is equal to 0. Let the common velocity of the bullet and the object after the bullet is embedded into the object is v. Okay. If we're going to proceed now with the law of conservation of momentum, we have m1u1 plus m2u2 is equal to the sum of both objects multiplied with the velocity. Okay. If we're going to rearrange the equation to solve now for v is equal to m1u1 plus m2u2 all over the sum of both masses. We're going to substitute now our variables. We have your m1 at 0.05 kilograms multiplied with the unknown u1 plus 0.45 times the velocity of the stationary or suspended object at 0 all over the total masses of the bullet and the suspended object. If we're going to further simplify the following, this gives us 0.05 u1 all over 0.5. Now, to solve for the value of the impact velocity of both objects, okay, we're going to consider another solution for the velocity as v is equal to the square root of 2gh. So this came from free fall equation. If we're going to substitute the value, v is equal to the square root of 2 multiplied with the gravitational constant of the Earth at 9.8. In this instant, it was rounded to 10. Multiply it with the height, okay, the height of the suspended object at 1.8 meters. So further simplifying the following terms gives us the square root of 36, or the velocity is equal to 6 meters per second. Substituting this in the above equation, the value of u1 is, okay, this gives us your v as 6 meters per second is equal to 0.05 all over zero point 0.5 of u1. If we're going to cross multiply zero point 0.5 to 6 and then divide it with 0.05, okay, as you can see here, 0.5 times 6 all over 0.05. This gives us your final answer for the initial velocity of the bullet prior hitting the suspended object at 60 meters per second. Now that concludes this example. For further questions, you may message me through my messenger account or our LMS inbox. Thank you for listening.